Hey, Drip Zero here at the charging table. Zoom. This table is where I charge all of my devices. So this, and it's a wireless charging pad here that I'm charging a Moto Mod battery pack, a phone, and the reason why it's a charging table is because it's got drawers with large batteries in them to charge a whole bunch of things. Down below, more batteries, but more about that later. This video is about this Turbo Power Pack from Motorola. This is a Moto Z mod, so you slap it on the back of the phone. The one I'm charging with, it would go kind of like this, right over the camera. And the one thing I noticed immediately is let's see if we can focus in on that. The input power rating on this thing is 5 volts, 6 amps. 6 amps. Now, I've never seen anything with that high of a current rating. 6 amps, especially for a battery. That's intense. So usually they say charge a battery at 1C, which is the capacity, 1 times the capacity. Now some batteries are rated higher than that, but what you want to avoid is overheating of the battery, because the life of the battery will be reduced if that happens. So 1C, so a 30, let's see, what's the capacity on this thing? 3,400? Yeah, 3,400, about 3,500. So 1C would be 3 amps. So they're doing about 2C at 6 amps. But I've got 2 chargers here. So this is the turbo charger from Motorola. And this is a normal USB-C power delivery charger. Supports up to, I think, 60 watts. And we're going to charge this thing with different chargers and see what happens, what they charge at. So you will note different behavior by each of these chargers. So this is the Turbo Power, or Turbo Charger 30 watt version, not the 15 watt. So let's plug this in real quick and swing around. So that is doing the 9 volt profile. Now, what I came to find out, I did a bit of reading before, the USB Power Delivery 3.0 spec allows the power supply and the client, the host and the client, to negotiate voltage 50 millivolts. So you can get very, very granular, constant current and constant voltage applications with it. So that might be why we're seeing 8.7, or it just maybe it's trying to do 9 and the power supply can't keep up. But 9 times 1.3, that's right around 15 watts. Now, if I were to, I'm not going to do it here because I don't have that charger with me, but if I plugged it into a Turbo Power 15, I would see even different behavior. I would see 5 volts, 3 amps for 15 watts total. So we're still not getting the 5 volts, 6 amps, but once we connect up our Turbo Power 30, we will see if that can do 6 amps. Okay, tricky with one hand. So let's get that going. Pop. And swing it around. So look at that. 4.5 volts, 6 amps. That's crazy. So why 6 amps? This is the only charger I've gotten to do 6 amps. This charger is capable of 60 watts, right? 30 watts, 5 volts at 3 amps, or 6 amps is 30. So it should be more than capable of charging this guy at 30 watts. How is this the only charger that works? Well, the USB 3.1 power delivery 3.0 specification says 5 volts, 3 amps max. And the reason is, and it has to do with why other voltages are available, is because the wires inside the cable itself, the connectors, so these connectors have little teeth in them, as well as the phone have little little teeth that connect with the wires. They have a current limit. They will get overheated if you supply too much power. So what I believe that the Motorola Turbo charger is doing is using more pins. It's negotiating with the client over using perhaps the USB-C protocol, and it's telling it's capable of turbocharging, and it's using more of the wires inside this cable to deliver the extra 3 amps. So probably double the wires going into that. And USB-C has lots of little connectors, and there's lots of little custom things you can do with those extra connectors if you can negotiate that. So laptops do what I believe is called lightning bolt over Thunderbolt over USB-C, and you can do all sorts of other things, HDMI over USB-C. But in this case, they're doing extra power, and that's how they're getting 6 amps. So it's actually gone down now, and allegedly there is some temperature overcurrent and over voltage protection going on inside the charger itself, according to a Motorola video advertisement I saw for this product. So that might be what's going on, as it's warming up. So again, 3C or 2C, 2 times the capacity is what these guys are charging at. Alright, that is my USB-C adventure for today. Very interesting. So this should charge very quickly at that kind of current going into that thing. Really cool. Alright, Drip Zero out.